And that recording will actually be sent out to everybody probably later on this afternoon. So just keep an eye out for that recording. You can go back, reference anything that's covered during the presentation. Also, the chat is open, so if you do have questions, feel free to post them into the chat. I will be monitoring the chat. I'm sure we'll have, Eric, we'll have a designated Q&A at the end of the session, correct?
Absolutely, yes.
Awesome. So if you want to hold off on questions towards the end, you can certainly do that. What I'll do is I'll allow people to come off mute at the end and ask questions. But if you do have some and you want to post them into the chat, please feel free to do that. Awesome. And then as people are jumping in, why don't we make sure everybody can use the chat? Post where you're logging in from today. Where are you located? And then Eric, if you want to share screen, you can certainly.
I'm working on it. Unfortunately, we're having some technical difficulties here. It's almost there now. Almost. All
right, so we have people logging in Seattle, Bryan, Texas. North Carolina, Texas, Arizona, North Carolina, Hawaii, Brazil, Maryland. Oh, we're all over the place today. I love it. And then one thing I did forget to mention, with that recording that you're going to receive, there is a quick questionnaire. We ask that you just take the time to fill that out. It should take you no more than 2 minutes. It's a pretty brief questionnaire as far as our career office here at WGU. We're looking for your feedback, any suggestions, anything specific that maybe you're looking to, maybe something that you'd wish that we did here in our office. So we're always looking for that feedback. So please feel free to provide us with that feedback. And like I said, that's going to come in the email with the recording of this event. So please feel free to go in and access that. Also, any of our other sessions that we have run throughout the Career Quest month, you can always go back and watch those recordings. Those are actually on our, if you go to careers, our careers page, you'll be able to click on the Career Quest specific link, and then it'll take you to that page with all of the recordings of all of the events we've done over the past month. So make sure that you're able to jump in there and access that. And Eric, we can see your screen, so we are good to go there. And what I'll do is I'll pass it over to you.
Okay, thank you, RJ. Welcome everybody. Thanks for taking the time to attend this little information session today. My name is Eric Legale. I'm the Associate Dean and Director of the 2 data analytics programs here in the College of IT at WGU. We have 2, and we'll go through sort of both of them, but the focus of today is really the master's program, our Master of Science in Data Analytics. And what I hope to convey to you today is the possibility of moving into MSDA from wherever you're coming from. As I'll describe in a moment, data analytics is this rapidly growing discipline that really encompasses a lot of different skill sets and backgrounds and industries and sectors and occupations. And there's really room in analytics for people from a wide variety of different places. And so the MSDA can help prepare a wide variety of different people to occupy those various occupations. So that's what I want to talk about today. As RJ said, we will have time at the end for questions. So please make sure to think of those as we're going along, and you can put them in the chat or you can wait and ask them in person. A little bit about me as we get started. I have been with WGU for more than 10 years. I started as an instructor here in 2013, and I've been a program manager, a senior manager, an administrative director, and now my current role is an academic director. So let's move on here. So the first question that many people ask, or many people have opinions about, is what is data analytics? So we'll start there. Our definition of data analytics is something that might be a little bit different from other definitions you've heard in the past or heard from other sources. And that's because data analytics, as I just described, is this rapidly growing discipline. And because of that, it's going in lots of directions at the same time. And so when people think of data analytics, they may think of a part of it. But increasingly, data analytics is this umbrella discipline that really encompasses a lot of different parts of an organization, a lot of different functions. So we like this definition here. This is a definition from my boss, the dean, Dr. Joe Derry. Analytics is the creative use of data and statistical modeling to tell a compelling story that not only drives strategic action, but also results in business value. So there's a lot of parts of that definition that we can draw from here. And I'll just point out a few that we'll cover as we go along here. So first of all is the word creative. Analytics is a creative discipline. It involves creative thought, it involves analytical thought, of course, and strategic thought and critical thinking, but really it's about creativity. How do I solve organizational challenges? How do I address those? Using data and statistical modeling. So of course, there's math involved in data analytics. There's no way around that. But really what we're trying to do is tell a compelling story. So as with many things in life, half the challenge of analytics is once you've developed a solution, how do you integrate that within the existing organizational flow or business processes? How do you take this new analysis that you've done and use it to drive strategic action within the business? And that's actually the hard part. It's very easy to develop, let's say, a machine learning model. It's very hard to get the business to use it, but that's actually what's affecting change within that business. And so this last part of the definition really speaks to that directly. You have to result in business value. Otherwise, what's the point of having done it? So said another way, a responsible program in data analytics is incorporating a lot of these different elements in it. So as we think about data analytics, we often frame it in terms of what we call a data product lifecycle. So you see one version of that here. You'll see another version in just a moment. But generally, the flow of data analytics projects is to, first of all, as I said, identify a business need, a business problem, and an area where we're actually doing data analysis could help. Second, take that data and turn it into actionable knowledge using data mining techniques. That's where your statistics and the programming and all of that will come in. Then third, of course, do something with it, act on the knowledge. And then finally, having done that, you measure the results of that action to determine, did it do what you thought it was going to do? If so, how much? If it didn't, well, that's interesting too. And that feeds back into the beginning of the cycle again, so that the new situation can be the subject of a new analysis or a further analysis. So this comes from a textbook, the Linhoff textbook. It's one that we present in our programs. And it's a way to think about data analytics and its role within the business, right? Again, you see here the idea that you actually want to affect change. You actually want to act on the knowledge, right? This cycle doesn't work without step 3. All right, so how do we then take that broad understanding of what data analytics is and turn it into a program? How do we design curriculum around it? What are the sorts of things that one might expect to see in an analytics program as a result of having set that definition? Well, as I described, there are lots and lots of data analytics roles. Data analysts are now found within most parts of a business. You can find data analysts within human resources, within sales, within product design, within all sorts of various places. And so IT, finance, they're really everywhere. And as a result of that, the roles are going to look slightly different depending on what function you're operating within inside of a business or an organization, and what the objective is. So the way that we think about it here at WGU is as 3 skill levers. Okay, you can see those on the left-hand side of this slide. And the 3 skill levers are programming skills, math skills, specifically statistics, and then business influence skills. And you need some amount of each of these, right? As I've described, if you don't have the business influence skills, you can't integrate the analysis within the business processes. You can't affect change. Of course, in order to develop the analysis, you need the programming and the math. And so all of these levers have to be set at some position above 0. So on the right-hand side, you can see a snapshot of the types of different occupations that you might see in job ads, for example. And each of these positions, because of the specific things that they're doing within their role, will require those levers to be set at different positions. So as you see on the left-hand side, the levers are all pretty much in the middle of the range for each of those 3 skill levers. And that's kind of where we set it for the undergraduate program. If you graduate with the undergraduate BSD-MDA degree, now the BSDA degree, you will emerge with those skill levers all pretty much set to the middle. A foundational or intermediate understanding in all of these different areas, which is appropriate for entry-level positions. In the master's program, as we'll describe, we want those levers a little bit higher, but not every role requires them to be all the way up. So if you look on the right-hand side again, you see this row, the data scientist row is highlighted in yellow. And that's because this is one of those roles where we do require those levers to be pretty much all the way up. You need pretty much expert level understanding in each of these 3 skill areas in order to be a well-functioning data scientist. That's why those positions are hard to come by, why they are very expert. They're so-called unicorn positions, and they're paid very well because they require that level of sort of cross skill area expertise. Other roles, like the data analyst role, which is a very common entry-level position within organizations, require the levers maybe to be set more in a medium position. If you're a data engineer, that requires a lot of programming, and so that lever might be farther up, and the business influence might be all the way, might be farther down, but not all the way down. As I said, none of these levers are ever at 0. And so you can begin to see in the table on the right for different types of roles, what are the different positions of the levers that one might want to have. So I take away 2 things from this slide. The first is that there are these 3 skill areas and that all the skill areas have to have levers set somewhere above 0. But second, there's optionality here in the sense that depending on what you're passionate at and best at, one can choose a role and therefore prepare for that role within a program by setting levers in different positions. And that's what we're all about here at WGU, is making sure that we are allowing learners to customize what they're doing so that they can have the role that they really want when they graduate. Okay, and RJ, just as a note, I'm not looking at the chat, so if you want to interrupt me, if you see questions that are popping up there, that would be very helpful. I can address them in real time.
Will do. No questions as of yet.
Okay, great. So the next question that many people ask is a career in analytics worth the investment? Obviously, to do a master's program is not a small investment of time or money, and so it has to be worth it on the back end. So what you're seeing here is from a tool called Lightcast, and this is a tool that we use to do some of our market research here at WGU. And this is showing the number of unique job postings in the data analytics space, defined fairly broadly, over the period from April 22 to February 23. So a little bit less than a year. And on the vertical axis, you can see companies whose names you recognize. And on the horizontal axis, you're seeing the number of unique job postings that organization put out regarding data analytics or data science over that time period. So lots of companies, first of all, and across lots of different industries and sectors. You see insurance here, you see finance, you see manufacturing, you see consulting, you see military associated things, all sorts of different industries and sectors are represented, and quite a strong demand for data analytics and data science positions. So definitely the demand is out there. This is a growing discipline for sure. The next thing that might be of interest then is to look at what are the typical salaries in those roles. That's a little bit harder to get at in the sense that because it's such a broad umbrella discipline, there's a fairly large salary range depending on what specific job title you're looking at. But generally speaking, if you look at the US Bureau of Labor Statistics, they identify the top 10 fastest growing occupations based on all the data that they look at. And you can see the data scientists here are on that list. And they're projected to grow 35.8% in terms of the number of roles within the next 10 years, or actually up through 2031. That's going to generate another 40,500, almost 41,000 jobs over that time period. And the median salary isn't half bad either. So these are positions that are high in demand. They are represented broadly across industries and sectors, and within a specific company, you can find analysts occupying multiple different roles within different departments. And those are well compensated because they're in high demand. All right, as we move on, this is another view of the data product lifecycle. And what you're seeing here is a little bit more granular view than you saw a few slides ago. And this is drawn as a cycle. Typical data analysis or data science projects don't always go in a neat circle like this. They'll jump it back and forth between different sections throughout the project as required. I think that's true of most projects. But it's helpful as a way to frame our understanding around the different parts of a typical data analysis, and then what are the different skills that are required at each stage. So starting in the upper right-hand side with the orange, business understanding. That's really key to any data analysis. It's understanding what is the actual business or organizational problem that I'm trying to solve here. And that requires skills in business influence, so stakeholder engagement, project management, system design, design thinking, meeting with the people who are actually doing the work to understand what is their need, what is their lived reality here, and how might a data analysis help them? How might an analytics approach help them with the challenges that they're facing? Next, the typical step is to acquire the data. So this is maybe the data is in a well-organized database already within the organization. Sometimes it's in a not well-organized database within the organization, and sometimes it's not present at all, and we have to go out and find it in the world. So data acquisition is the next skill set, and this involves skills in data wrangling, systems design, programming, databases, so data management. It involves skills in terms of various querying languages, which I'll talk about in just a moment. And then once the data is acquired, it of course usually needs to be organized and cleaned. So maybe the zip codes are all in different formats. Maybe there's missing data. Maybe there are outliers. How do we handle that? How do we identify those opportunities within the data and fix them? And so that's, again, skills in data wrangling, skills in programming, stakeholder engagement, right? Do we really need those extra 4 digits on the zip code, or is just the first 5 okay, right? So questions like that are very important to understand the level to which we are organizing and cleaning the data. Once we have the data finally in a format where we can conduct a responsible analysis, we can go and do some preliminary exploration. So this is easy charts and graphs from the data, looking at the various data types in the columns. What are the ranges of those values? What are the data types? Are they continuous data? Are they discrete data? And so forth. How are things maybe related to other things at a very high level using the data that we have? So again, skills in data wrangling, programming, stakeholder engagement. So looking at possible relationships to see if interesting trends drop out right away. Talking to stakeholders about that. Is this something that you expected to see? Is it something that you've never seen before? From there, moving on to more advanced statistical modeling. So data mining is a term you may hear that we use sometimes. But generally speaking, it's predictive modeling. So if I know what happened in the past, can I predict what's likely to happen in the future? So what are the sales going to do? So forth. What's my attrition going to be in this company, right? How many customers might I lose? All of that involves skills in statistics and probability, and also programming. Then finally, the most advanced side of analytics is sort of this machine learning side. So can we set up a machine learning model that will automatically adapt and adjust itself over time to maintain the accuracy and the precision of the analysis? So as the data drifts, as it changes over time, as the customer segments evolve and mature, can my analytical approach handle that? And some of the techniques in machine learning can help that happen. So this is where we're starting to get into more advanced computer science topics, machine learning operations. How do you deploy a model like that so that it runs in the background constantly? And all of that involves skills in programming. And then finally, the sort of wraparound piece, which is communicating the results of the analysis to the various stakeholders. Hopefully you've been doing that in stages all the way along, as I've explained, but there's usually a final report or a dashboard that's created. And this is involving skills in data visualization, storytelling, change management. How do you actually help the people side of change here, and decision intelligence? So how is this new analytical approach going to adjust how decisions are made within the organization? Excuse me. So that's broadly speaking, an analytics workflow and a data product lifecycle. So you'll notice here that I'm not talking a lot about specific tools. Excuse me. I'm coming off a cold. And that's intentional. What we've focused on here is the skills. And the reason why is that the skills are adaptable. Because analytics is changing so rapidly and growing so fast, the exact tools that we use will change over time. So the programming language that we use today may not be the programming language we use tomorrow. But the skills in programming will remain constant in the sense that if you know how to program an algorithm in one language, it's much easier to learn to program the same algorithm in a second language than to learn to program the algorithm in the first place. So we focus on the skills, and the exact tools are important, and we do teach tools in the program, but they are less important than the actual skills. So we will talk about some of the languages and tools as we go through here, but you can imagine putting in certain programming languages here in the data cleaning and the data exploration side, using query languages like structured query language or SQL, as it's sometimes called in the data acquisition phase, and so forth. So because we have a broader audience today, this is a question that I often hear. Will my prior schooling help me succeed in the MSDA program? The broad answer to that is yes. And here's why. Analytics, as I've described several times now, is an umbrella discipline. What that means is that it is encompassing a wide diversity of backgrounds and thought. And it requires that in order to create successful analytics. So analytics has to be diverse in order to be successful. That means it has to bring in people from all sorts of different educational backgrounds and all sorts of different backgrounds in terms of their lives and their work experience. So we seek to make our MSDA program as inclusive and cross-disciplinary as we can. We've had students from backgrounds as varied as physical education teachers, firefighters, all sorts of different people come through the MSDA program. And that's, as I said, essential to its success and success of analytics as a discipline. So more specifically, what are the skills and competencies that we teach in the program? You can see sort of a first cut of that here on the bottom of the slide. But on the top of the slide is really those kind of foundational competencies that we find help students be most successful as they enter the MSDA program. It is a rare student who has all of these foundational competencies in hand as they come into the program. More often they'll have strength in one or two of these areas, but not all of them. And that's okay because our program is intent on helping folks from varied backgrounds succeed, which means that we have to scaffold in that learning appropriately. But some of the things that we find tend to make students successful, some experience with math, obviously, I think hopefully that makes sense. Probability and statistics, understanding the foundations of that. What are probability distributions? What are the various ways that data can be distributed? How are we typically measuring those spreads? So central tendency and means and medians and modes, standard deviations, things like that. Applied algebra, mathematical reasoning more generally can be very helpful. How do we solve problems mathematically and the, sort of the symbology of that? Looking at an equation and sort of being able to pick apart what the major features of that equation are. Some understanding of programming is very helpful as well. So not necessarily to the level of being an expert programmer in any language, that's certainly not required, but understanding algorithmic thinking. How do I take a problem or a process that I'm trying to get to happen and break it down into pieces, each of which could be parts of a program? So things like, do I need a loop here? Do I need an if statement? Do I need a case statement? even independent of the language we're talking about, this idea of being able to do that algorithmic thinking, that whiteboarding of a problem is very helpful. And many people come in with those skills already. Um, Understanding data management in SQL is very helpful. What is a database? How do databases work? What are the different kinds of databases? How do I get information into and out of a database? Some of you may already have had those skills in various programs at WGU. I know that folks from the College of Business take courses in databases over here in the College of IT. And yeah, these skills are widely represented in various places. Machine learning and scripting and programming, that's helpful if you know it. If not, those are the sorts of things that we can scaffold in, but students coming from the College of IT often have a lot of that in hand. And then on the right-hand side, business influence skills. So these are the communication skills, the writing skills, verbal presentation skills. Uh, how do I think about systems? How do I think about change management? How do I think about project management? Those are the various skills that are commonly represented in programs across WGU and elsewhere, and can be very helpful in understanding the context in which we're doing analytics. So what do we do within the MSDA program? Well, we're moving all of those skill levels up a little bit, right? So we're talking more in depth about statistics. You will do math in the MSDA program. There's no way around that. Analytics is based on math. It's based on statistics, and so there's statistical learning that goes on there. How do we do regressions? What is a regression? How do we do various types of machine learning algorithms, right? What are the theoretical underpinnings of those various algorithms? How do I choose one type of machine learning model versus another? Programming skills. So we teach skills in 2 languages in the MSDA program. Students are free to choose either one, but we expose them to both in every course, those being Python and R. R is a statistical programming language that's historically been used very commonly in analytics. It's less used, I would say now, but still very common in certain sort of fields, environmental science, ecology. Those types of folks still use R quite a bit. And various businesses will be R focused as well. Python is very common and rapidly growing programming language. It's used for things, of course, beyond analytics. You can program websites in Python. You can actually do the same thing in R too. But we're focused on this on the analytics side of it here when we're talking about the MSDA program. Advanced analytics. So that's getting into topics like deep learning and natural language processing, some of those more advanced techniques that are really foundational to a lot of the things that are going on in the world right now, artificial intelligence more broadly. And then business influence skills. So we really do focus on storytelling and the data presentation aspects. How do you create dashboards that are interactive? How do you present the information in a way that a given group of stakeholders will best absorb it? So if we're presenting to C-suite executives, that looks very different than if we're presenting to our peers. And we need to understand those differences in order to make the presentation effective. So we spent a fair amount of time in the MSDA program talking about that. But more than likely, you already have a lot of the competencies in hand that you would need in order to be successful in the MSDA program. So what else should I know about the MSDA program? There's lots of information and I can answer questions here. Suffice it to say, this slide shows us a little bit more about the structure of the program. So it really emphasizes, as I described, the data product lifecycle. It's designed around that lifecycle. So if one looks at the courses and the sequence of those courses, it's all really based around the sequence of steps in the data product lifecycle. So it's really at each step, we're teaching just the skills that you need at that step, whether that's programming, whether that's math, whether that's business influence. All of those come in at various stages throughout the life cycle. And so we present them like that. Our curriculum covers programming. I talked about Python and R. Statistics, different types of statistical tests, parametric, non-parametric tests. It talks about machine learning, supervised, unsupervised methods, so clustering. It talks about various types of machine learning models that are supervised. Supervised models, by the way, for those who may not be familiar, are those where we already have the data, what we call labeled. And so, for example, we already know if the customer left the company or not, right? In some cases, we have that information. Other cases, we don't. Where we don't, that's called unsupervised learning. A lot of skills in data management and SQL. How do we get data into and out of databases? That's a core part of what an analyst does in any role. Tableau is the data visualization software that we use in the program, and students work with Tableau and create presentations and dashboards. There's also lots of data presentation in other ways, whether that's verbal presentation, videos, written communication, and so forth. And then, as I mentioned, we talk about these advanced analytic techniques as well. So neural networks, deep learning, market basket analysis, natural language processing. There's a few in there. So all of those are ways that we will help graduates from the program be prepared for a wide variety of different challenges that they'll encounter in the workplace as they get started and encounter interesting opportunities to apply analytics. On the right-hand side, you see that there are 3 embedded micro-credentials that all students in the MSDA program automatically receive as they complete courses. And this is important because it's a way to actually demonstrate that you're acquiring these competencies even before you graduate. And so it's a way to post these digital things on your LinkedIn profile and link to them from various places to demonstrate to prospective employers, even while you're still in the program, that you've developed these competencies. And these are measures of competency that we can recognize here at WGU in smaller chunks, and that's what these certificates are. So there's one in data preparation, there's one in data analytics fundamentals, and then there's one in advanced data modeling. And there's nothing additional that anybody has to do to receive these. One simply receives them automatically as one completes courses. So looking at the standard path, this is taken from the website. So you can look at the landing page for the program and you'll see the same information. Those are the courses. So you've got 11 courses, including the capstone, 31 CUs total. And the 6-month tuition and fees, all inclusive, are shown there. And that's the same information that you'll find on the WG website. So starting at the beginning, understanding what the data analytics journey is, what is that data product lifecycle in depth? Then, as I said, we go along and follow the data product lifecycle. So data acquisition, cleaning, exploring the data, predictive modeling, data mining, and then representation and reporting is our visualization and communication course, and then more advanced techniques as well. So finally, there are opportunities for students who are coming from programs already at WGU. So if you are a student who's coming with a bachelor's degree from WGU, the so-called continuing graduate, you'll be an elite applicant for a master's degree. You can enroll more quickly. You can apply for alumni-only scholarships, and information about that can be found in your student portal. And so there's a returning grad application, and then you could apply for the Alumni Master's Scholarship as well. So those are opportunities to check out as well if you're coming from a WGU program, no matter what college or what school you're in. All right, that's pretty much the information that I have to share today. So I will stop talking now and open the floor for questions. I'm happy to answer questions about data analytics in general, about the program, and any other questions you might have for me.
And as people are coming up with questions, feel free, if you want to take yourself off mute, you have that capability where you can ask Eric any questions that you might have, or if you just want to post them in the chat, feel free to do so. You're able to do that as well. Eric, I did have a question. You know, obviously our programs here at WGU, we really try to align with industry standards. Specifically for this program, can you kind of just touch on what work has been done with that as far as keeping up with current trends within the industry?
Yeah, it's a great question, RJ, and one that we often commonly get as well. Because it's such a rapidly changing discipline and so growing and evolving in different ways, we are constantly looking at our curriculum and matching that to what the market is telling us our needs at the current time. So at a high level, when we originally developed the program, we fairly much developed it as an IT program. That's why it's in the College of IT. But analytics has grown so much since that initial conception that it's much different now. And so we're constantly tweaking courses and changing courses, and we are always doing market research, whether that's research into job demand. So what are the jobs, where are the jobs, but then also what are those job ads asking for? And we have a well refined sense of that because we have entire teams at WGU called our skills architecture team, whose sole job it is to go out, understand what the job demand is and what are the skills that are being asked for in those individual job ads, and then looking at and mapping to our curriculum to figure out, okay, what skills are we covering versus what are the skills that are being asked for and where are the gaps. And once we understand those gaps, then we can revise the curriculum, which we do pretty much continuously at this point, to make sure that we're constantly aligned with that. And this skills denominated approach is something that's unique to WGU. Not a lot of schools will do that. And we are a founding member of something called the Open Skills Network, where we're really trying to get everybody talking about skills in the same way. And so the Open Skills Network, what they try to do is they try to come up with this machine readable format for skills and a common taxonomy, such that we could talk about skills here at WGU, and those would be the same skills talked about by companies in industry. And so they would say, we need this particular skill, which we designate with this number, and then we can point to our curriculum and say, oh yes, we've represented that skill explicitly in this course right here. And so that's an effort that's growing, that's ongoing. But WGU is really committed to making that happen because it's a sort of a lingua franca, if you like, of skills. And so everybody's talking about skills in a consistent way. So we are constantly doing that. We have entire roles. We have a lead academic program manager whose sole job it is to track that information over time, and then also to do competitive analysis, right? Where are other programs in data analytics strong and where are they not strong? One of the things I think you'll find if you look at this program in particular compared to other programs is this three-lever model. That's something that's not widely represented, particularly in master's programs. You tend to find master's programs in data analytics or data science coming out with one of two flavors. Either they're very strong technically, so they're very in-depth in terms of the programming and the math, but relatively weak on the business influence. Or you'll find programs that are more like MBA programs where they tend to be very strong in the business influence, but less technically deep. And what we're trying to do is strike that balance in this program so that you're getting the technical depth and you're getting the strength in the business influence skills. And that, I think, puts us at a relative advantage compared to a lot of the other programs out there.
Thank you. We did have a question that popped up in the chat. Will this program help with starting a career in data warehousing or business intelligence?
It's a good question. So I would say we do cover concepts in data warehousing. It is not a data management or a database management program. That is not where we spend most of our time. We do talk about those concepts. You can certainly learn to set up a data warehouse in this program, but it's a data warehouse in service to doing data analytics, right? So it's really understanding how to analyze the data from the data warehouse in a way that can answer business questions. So I would say, yes, it's part of the program, but it's not a main focus. In terms of the business intelligence piece, that again depends on what you define as business intelligence. A lot of this terminology is fungible right now. And different people will call the same things different names because this discipline is still emerging and growing. So some places will call a given position a data analyst, other places will call it a data scientist. I like to joke that if you get 10 experts in a room and ask them what the definition of data analytics is, you'll get 11 answers because it is changing, it is growing. So when I think business intelligence, I think more about the organization and the making sure that information is presented across the business in ways that are scalable and understandable. So a lot of the dashboarding, but then also a lot of the back end data organization, data governance. And so there again, we talk about those concepts in the program, but it's probably not the main focus. The main focus is really how to do these statistical analyses on the data in such a way that you're affecting change within the business and driving business value.
another one popped up in the chat, and bear with me because it is a longer question. Um, this individual is completing their MBA at WGU next month. Their company is talking a lot about data analytics, and they're wondering what resources you recommend to upskill in this area, if not taking the MSDA,
Mhm.
or just asking in a different way. Do you recommend taking the full MSDA if you already have the MBA, if you're not looking to work specifically in data analytics, but would like a better understanding in what info can be gleaned from data analytics and how to translate the data to identify and solve problems and define and measure KPIs?
Yeah, great question. And so I think first of all, congratulations on almost finishing the MBA. That's a huge accomplishment, and very exciting. I would say that if it's not a core focus, then probably a master's degree might be an extra investment beyond what's required for you. There are lots of great resources out there now. I would focus on making sure that you've got the core understanding of what is required to do data analysis. And the MBA will give you a lot of that stakeholder engagement and a lot of those business influence skills. And so that's great because that will already be a strength for you coming in. You have the ability to talk to various parts of the business, communicate, and understand what the needs are, right? Then the next question is what to do about it. There, I would say some of the core skills that can really be helpful is understanding if folks who know how to get data into and out of databases are always useful in organizations. So I might actually start there, is looking at resources that teach you about data management, data governance, and query languages like SQL. And there's lots of free resources out there. There are lots of courses at vendors whose names you'd recognize, right? The Pluralsights and Udemy's of the world are rife with courses on data management. And that's great because it teaches you not only how to query databases, but it also teaches you how are databases structured, right? And that tells you a lot about how the organization thinks about the data that it has, right? What's important about that data such that it's structured this way. Beyond that, then getting into some of the typical types of analyses that are done. Most organizations don't require really in-depth statistical approaches to answer a lot of the questions that they have. Often regressions, simply linear regressions or sometimes logistic regressions will get you where you need to go. You don't need crazy machine learning models to do a lot of these things. Sometimes it is required. And so that's, I would say, downstream though. So I would say probably the data management and SQL stuff, getting a handle on that, understanding that, and then really understanding a little bit about the typical types of data analysis approaches that are used, statistical approaches and machine learning approaches at a high level can be very helpful to work within the business, simply such that when folks come in and say, well, I think we need this here, you can stand up and say, well, actually, maybe or maybe not, and here's why.
We had a question as far as will they have access to these slides, and this was recorded, so you will be able to go back and rewatch this recording. Keep an eye out for that later on this afternoon. At the very latest tomorrow morning, you'll be able to access this presentation. So keep an eye out to that via email. Does anyone else have any questions? Feel free to post them in the chat or come off mute and ask whatever you might be wondering. All right. right, doesn't look like any other questions. Well, Eric, I do want to thank you for jumping in and presenting today. I know valuable information. Oh, we did have one that did pop up. What are the major industries that most graduates of the program end up working in?
That's a great question. So we find a fairly high concentration of folks going into sort of the healthcare, health insurance side of things. And then we find a fair amount of folks working in finance. Those would be probably the two biggest ones, but we find a wide variety of different industries and sectors represented. So we're always interested in talking to various organizations to figure out what their needs are, because the needs by industry and sector are of course different. So we do have an IT advisory council that talks broadly to folks from a wide variety of different places. But those would typically be the top two to which our graduates end up going.
And another question popped up. How competitive are these roles relating to data analytics in terms of landing the positions?
It's a good question. So within data analytics, the entry level position is usually called something like a data analyst or a junior data analyst. And there's it's not as competitive as the upper echelons of data scientist. And that's because the level of expertise that those positions are usually asking for is not as high. And so it's certainly possible to get data analytics positions coming from a wide variety of different backgrounds. A master's degree is tremendously helpful in that approach, though. You can certainly work on getting it with an undergraduate degree. The master's really shows that you have that additional level, that you've moved all those levers, those skill levers up a little bit compared to other folks. And so that's a competitive advantage for sure.
Any other questions? All right. Well, Eric, thank you again for jumping in, presenting. I know we greatly appreciate it here at our office, and I'm sure everybody on the call will appreciate this information, as well as those that are able to watch the recording. Thank you everyone for jumping in today. We greatly appreciate it. Some fantastic information, and make sure you keep an eye out for that recording. If anybody does have any follow-up questions, don't hesitate to reach out. You can reach out to us at our careers at email if you do have any questions, and then we can get those directed to Eric. But we thank you all for jumping in today, participating, and I hope everybody has a great rest of your day.
All right. Thanks, everybody. Thanks for coming. Have a great day.